Hey everybody, and welcome to our last topic of the year. We're going to talk about some statistics, and we're going to do it a little bit different than I have been doing in these other modules. And the reason is we're sort of out of time here, so we got a week to get as much of this done as we can. And I think what I'm going to do, or I've decided, is that we're basically going to get into the EOC released form and do those problems. Instead of having a whole bunch of templates and notes, I'm going to find the problems. And you can write down notes as you need to, and I'm basically going to work out the EOC problems. Then I'll assign you like 5 problems to do, and there's probably going to be about three of these things. But anyway, today's topic is linear regression. We have done this before, so this probably will be a fairly easy one, and I'll be using the TI-84 calculator to do everything. So I want to show you where I'm getting this from, and I'll put a link in our homepage to those of you that'll follow this. All right, so I'm on the release form EOC, Math 1 released items, and I'm looking at number 31. And I'm not doing these in any order other than I guess some are better at explaining the easier concepts than the others. So I'm starting on 31, and we'll do 31, 37, and 16. So number 31, let's read this thing together. Now, it says the table below shows the U.S. average life expectancy at birth in years in various decades. All right, and these are years since 1930. All right, and then you can see it goes up in increments of 10, it looks like, and we see the life expectancy in the Y column, and this will be our X column. All right, and it says, what is the meaning of the slope of the linear best fit equation for the data? Well, I would take this as an opportunity to just show you how to make one of these equations. And you'll notice here that we're in the calculator active section. So this, what I'm doing is totally legit. All right, so what a person would want to do here, now we want to talk about the slope, but first we have to find it. And we got to use all of this data to do so. So one thing when you work with linear regressions in the TI-84, remember in your mode, you need to turn the diagnostic on. Stat diagnostic needs to be turned on, and it's a default off. And I'll explain why when we get to that piece, but you need to turn it on in case they ask you something about the correlation coefficient. All right, so I've turned that on, and now we're going to go right to work. Okay, so what I need to do is enter this stuff into my L1, L2. So you're going to access your stat menu, and you're going to edit. And for the sake of this video not just getting long and incredibly more boring than it might already seem, I've already entered the data in L1. That's my X. And I entered the data for L2 into my Y. And the next move would be stat. You're going to calculate. And we're going to do some other stat stuff too. So write this down. You're doing linear regression. And it I just went too far. And it kind of reminds you of linear regression because it's called lin reg. So think of that as linear regression, and it gives you AX plus B. So I'm going to hit enter here. All right, yes, we're using L1 and L2. And I'm going to calculate this thing. All right, so there's my linear regression equation. All right, notice instead of M, like we always talk about Y equals MX plus B, they've used A. All right, so A is the slope of your line. There's the value of A, so the slope is about 0.2 or 0.21 if we're going to round it a little bit. And your y-intercept here is 62.9. Okay? Now we'll talk about what all that means in a second here. And here's that correlation coefficient. Remember, the closer it is to 1, the better the fit. So this is a 0.98, and we would say it's a pretty good fit. But they're not asking us that. They're asking us what's the meaning of the slope. What's the meaning of the slope? And notice they're using something down here with sort of like the y-intercept, I guess, but that's not going to be it. The predicted life expectancy at birth in 1930 was 62.7. That doesn't have anything to do with our slope, does it? Or I guess you reverse it, subtract that difference off. Yeah, I guess you could relate it that way. But to me, it's pretty clear to D because it says the average life expectancy at birth increases by about 2 0.2 each year. Now we have a positive slope. And remember, slope is a rate of change. So our rate of change is 0.2. So that sounds pretty decent. Let's see if these others make sense. The average life expectancy at birth increases about 6.7. Not true at all. Well, the difference in these values is 6.7, but that's not the slope, right? The slope we know is 0.2. So they're trying to mislead us and just give us some kind of number that we can find by adding and subtracting and things like that. I'd call that a distractor. The predicted average life expectancy at birth in 1930 was about 57.6. Let's see, would that be true? We would say it might be, but that's still not the slope. Okay, so it's obviously D. Final answer. And I'll see you guys in the next little short video about linear regressions. We're going to do another one.